So today I'd like to do a little bit of a demo on some ideas for winding toroids. Winding toroids in an RF career is probably one of the most hated things that either a ham radio or even a professional uh, engineer is going to want to do. I have about 1,000 of, or actually, yeah, about 1,000 of these toroids to wind. They're about 3 turns, or not about 3 turns, they're exactly 3 turns, spaced 120 degrees apart, and then there's a piece of tape that gets put over. And to me, it's very important that the lines stay parallel, that the orders stay correct. That really makes the manufacturing easy. When I did the first, about 150 of these, I used this fixture right here, and it was killing me. The basic idea is that 2 wires go in here. A toggle clamp like one of these guys would be over here on this portion right here holding it down. And then I would manually bend the wires over and through, make sure they're all lined up. And my wrists were not happy with that, to say the least. So with another 900 of these to make, I said to myself, something's got to change. So if you've ever had to wind a toroid, this is hopefully maybe something that will help you doing what you want to do as far as your toroid winding. What I've got here is a 3D printed fixture. It has got two toggle clamps on it. It's made out of SLA resin. It took about 6.5 hours to print. And the basic way it works is you take your toroid, and this is a pair of toroids. These are 1/2 inch by 1/4 inch thick toroids, same trade number as like an FT50. And that goes in here, the bottom. Close the toggle clamp to hold the core in place. Now what I can do is wind the wires up and through, and thankfully it doesn't matter which orientation they are, if it's orange black or black orange. And I line these up so that the toggle clamp can grip onto them. Now I have a good grip on these, and that's important. Really makes life easy that this is bolted to the bench, and that you don't have to hold on to it in 2 ways. So now I got this idea from Dick Fry, K4XU. Thank you, Dick. I owe you lunch. And this is a custom tool I made. This is a piece of 304 stainless steel welding filler rod that I've bent as about as flat and sharp as edge as I can. You could probably make something smaller than this. You could probably make it a hook. This is a 3D printed PLA screwdriver handle I found off of Thingiverse. I modified the SolidWorks design to have 2 holes in it rather than just a hole for the, I think they were using like a 1/4 inch standard bit or something like that. So I removed all that and then just ran the wire through, just bent it over at the end, and now I have something that can reach up and through. So the idea is that Dick told me that when they were winding large toroids at, I think it was 10 Tech or Harris, what he said, the operators would have a machine that would pop a bobbin up through the core. Now I don't, and then with a foot pedal, it would just suck it back down. Now I don't have a machine to do this, but this is good enough for me as it is because realistically, this is very ergonomic. So all I'm going to do is run the hook up and through, kind of see what's going on there. Run the wires through. I'm going to make sure that they're parallel, that they're not crossing over, but that's really easy to do. Make sure the camera can see that. And then I just pull it through. And that's going to lay the wires very clearly on here. Now, if you need to do a whole bunch of turns around the toroid, that's going to be a problem with this particular setup. You may have to do something where you can clamp around the turns. For this particular case, though, I only need 3 turns. So I can bring it up and over. Goes through, and I get a near perfect lay on the toroid. Do it one more time. So I just kind of lay it over this way. I'm right-handed. I should have put it on the other side. So now I can just go through here, put it through, and I'm done. Click and click. Out this pops. Then all I need to do is spread the coil windings out. And this is important just for capacitance. You want to get the capacitance as minimal, or the coil the winding to winding capacitance. And now This part is ready to have another piece of tape put on it. So I put another piece of tape over this. And then these then go, in this particular application, go into this little plastic enclosure. These drop in with some hot glue. Got the hot glue gun over there, it's not running. So after this has been taped, it looks like this. So there's 120 degree spacing. It doesn't have to be exactly 120. This might push the way it is. It might get pushed here. So these get hot glued in place. And then each of these windings, once this is nicely in place, I'm just going to do it with this one since this one's not done yet. Just imagine that this is glued in place. One of these wires goes over this way, down through into these little holes here, and I can wrap the wire around. Now I do this with a pair of pliers on the end because I don't care what happens with these wire ends. Same thing over here. These get wrapped like this, and then I put a dab of epoxy on both sides here and here to hold the wires in place, at which point then I can come back with a pair of wire cutters, cut off the leads right here, so on and so forth, and the whole thing pops out. And I end up getting, and then I can strip the wires using this wire strippers that I've got that can get in real close and flush. That's the particular application here. Just if you're wondering why the heck I'm doing this. As a quick demo, what I'd also like to do is that this method, when I was doing it this way, took me 1 minute and 30 seconds to wind each one of these toroids. That include preparation, putting in the toroid here, clamping the wires, and all the operations around it, including spreading the coils out at 120 degrees. So what I'd like to do right now is just do one. What I usually do is I take all these wires and I cut them up in bulk. So I'll get like 100 of each color, and then each time I need one. So let's see how long this takes me now. So previous record was 1 minute and 30 seconds on average. Here we go. Done. Yeah, that's a heck of a lot faster than 1 minute and 30 seconds. But I thought maybe there's need to be something out there, because when I looked on YouTube, I could not find anything on good toroid winding other than using one of those large toroid winding wheel bobbin things. And that's not really going to work for something like this. So anyway, this gives you an idea for winding a toroid. I hope it helps. Good luck and thanks for watching.